Right. Amines. See, amines are nothing but the derivatives of ammonia. NH3 is the ammonia. So in place of any one hydrogen, if R group is there, R and two hydrogens, these are amines. These amines are three types. Example, methyl amine. If two methyls are substituted on nitrogen, then three methyls substituting on nitrogen. Primary, secondary, and tertiary. Primary amines, secondary amines, and tertiary amines. Do you know the words primary, secondary, tertiary?
Yes, sir.
Right. So here, this amine group attached carbon is this one. This carbon is okay. The amine is connected with only one carbon, that is primary. Here, this is the amine group connected with 1 and 2. Two methyl groups or two alkyl groups are there, that's why secondary. This amine group means nothing but nitrogen. Nitrogen is connected with three groups, that's why it is tertiary. Okay. So here, important point is all these three are functional group isomers. Functional group isomers. Primary, secondary, and tertiary amines. Of course, these three are not, because here only one carbon, two carbon, three carbons are there. Okay, but functional group isomerism, the example is like this: CH3, CH2, CH2, NH2. It is a primary. CH3, CH2, NH, CH3. Here number of carbons, nitrogen, hydrogen, everything same. That's why these are functional group isomers. Now you can see 1, 2, 3 carbons, 1, 2, 3 carbons, 9 hydrogens, 3 to 5, 5 plus 4, 9, 3 plus 3 plus 3, 9. This is the tertiary. This much clear, primary, secondary, tertiary amines?
Yes, sir.
Okay. So here note point is functional group isomers. If you take primary, secondary, tertiary alcohols, in that alcohols, those are not functional group isomers. But here, these are functional group isomers. Right. Structure. It is similar to ammonia structure. If you take ammonia, it has one lone pair. Hybridization is sp3. Trigonal pyramidal. Trigonal pyramidal. So similar, this one also same. Trigonal pyramidal, here it is a lone pair is there. In place of hydrogens, R group, methyl group is there. So pyramidal shape of trimethylamine. Simply written pyramidal, but we need to mention actually trigonal pyramidal. Trigonal pyramidal. So here one lone pair is there, it's okay. Then bond angle. Bond angle generally, in case of NH3, the bond angle is 107. If you take methane, there the bond angle is 109. 109.5 degrees. In case of methane, hybridization sp3. Here also sp3, but 107, around 2 to 2.5 degrees less. Why? Because lone pair. So it is similar to nitrogen only structure, but instead of 107, it is 108 because the big bulky groups, little repulsion is there. Instead of 107, 108, little more compared to NH3. Understood? This is the sp3 tetrahedral. In generally 109.5, it is a stablest. Because of lone pair, repulsion is there, those sigma bonds coming to closer, that's why 107. In case of methyl group, big groups are there, that's why repulsion is there again in between the groups. Compared to NH3, little bit more, that is 108. Understood these three?
Yes, sir.
Right. Then classification, just now I given you primary amines, 2 alkyl groups, secondary amines, 1 and 2, then tertiary amines, 3 alkyl groups are there. Then nomenclature. Nomenclature, common name and IUPAC name. In the common name, amine is common. In the common name, amine. So this alkane group is taken as substituent. So this is the ethyl as a substituent, ethyl plus amine. In IUPAC name, ethane plus amine. Ethane. Ethane plus amine. Here 2 ovals are there, that's why this E I am cutting, ethanamine. This is IUPAC. In the common name, this alkyl group taking as a substituent type. Suppose here is there, one side methyl is there, one side ethyl is there. Alphabetical order, ethyl, methyl, amine. But in case of IUPAC, hello?
Yes, sir.
Yes. In case of IUPAC, we have to take the long alkyl chain with nitrogen. So ethanamine. Now what about this methyl? Methyl is a substituent. But methyl, where is the methyl? Methyl is present on nitrogen. So N-methyl is a substituent. Remaining ethanamine. In common name, one ethyl is there, one methyl is there, amine. Ethyl, methyl, amine. But IUPAC, the long chain we are taking along with the nitrogen. The name is alkylamine. Alkanamine. The common name is alkanamine. Alkane plus amine. Alkanamine. Alkanamine. Where? In IUPAC. This is the substitution. So similarly, this compound you can see. Ethyl. Substituents. What is the long chain here? This is a long chain. The long chain, along with the long chain, nitrogen is there. So 4 carbons. That's why butanamine actually. Butane plus amine, butanamine. But in the butanamine here, ethyl groups are there. These are present on nitrogen. So ethyl, diethyl, where it is on nitrogen. So N comma N. N comma N diethyl butanamine. Are you getting?
So I'm getting a little confused. So on nitrogen, how many other bonds can we make with carbon?
3 only nitrogen on 3 on nitrogen only 3 bonds are there.
Because nitrogen atomic number is seven. Is it seven?
7
It's seven.
nitrogen, 1s2, 2s2, 2p3. This is the helium. Then 2s2, 2p3. So nitrogen, one lone pair is there. Here single electron, single electron, single electrons. If NH3, if we take, here one hydrogen, hydrogen, and hydrogen. This is only I can write like this, NH3. In place of hydrogen, if I take alkyl group, NR, R, R, lone pair is there.
Yes.
Understanding?
Yes, sir.
So when we are taking nomenclature, CH3, CH2, 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 nitrogen, NH2 is there, suppose. 1, 2, 3, 4, 4. Butanamine it is. It is
Yes.
butane plus amine, butanamine. IUPAC I am writing. Is it done? Clear?
Yes, sir.
So in place of one of the hydrogen here, suppose methyl is there. Then second compound is what? Butanamine is common. Here one methyl extra is there. The methyl is present on nitrogen. So
N-methyl butanamide.
N-methyl butanamine. N-methyl butanamine. Suppose this hydrogen also substituted by one more methyl. Then third carbon. Two methyl groups are there present on nitrogen. So N comma N
Dimethyl.
dimethyl butanamide is a common.
Yes, sir.
Okay. So the long chain we have to take. Long chain is with nitrogen. Remaining, these are substituents. Done?
Yes, sir.
Next.
Sir, but how can like C2H5, how will the structure be then?
C2H5, what is C2H5? C2H5 nothing but here CH2, CH3. This is only C2H5.
Oh,
Instead
yes,
of
sir.
writing CH2, CH3, they written C2H5. 2 carbons, 5 hydrogens.
Yes, sir. So it will be N-ethyl
Uh,
and okay. Yes, sir.
if 2 ethyls are there, same name, N comma N diethyl butanamine. Suppose one ethyl and one methyl is there. Suppose in this case, here ethyl is there, right? So the fourth one, N-ethyl, then N-methyl butanamine. N-ethyl, N-methyl. Alphabetical order we are writing. N-ethyl is first, then N-methyl.
Yes, sir.
If both are ethyls are there, N comma N diethyl, same. Just M cancel, remaining as it is. N comma N diethyl butanamine. If 2 ethyl groups are there.
Yes, sir.
Next, CH2 double bond CH2 NH2 is there. Then CH2 double bond CH2 NH2 is there. So here, this carbon is called vinyl carbon. vinyl carbon attached with amine. So vinyl amine. Vinyl amine. Here, the unsaturation next carbon. This carbon is called allyl carbon. Therefore, this name is allyl amine. Allyl amine. Unsaturated carbon directly NH2, that is vinyl. Unsaturated next carbon, this is alpha carbon. Alpha carbon, so that is allyl. Allyl amine, vinyl amine. Got it?
Yes, sir.
Suppose here OH is there. Here OH is there. Vinyl alcohol. If chlorine is there, vinyl chloride. That means vinyl means this is a carbon. If chlorine is there, chloride, OH is there, alcohol, NH2 is there, amine. Similarly, here, if OH is there, allyl alcohol. If chlorine is there, allyl chloride. Like this.
Yes, sir.
These are over. If you can see here, CH2 taken 6 times is there. That means hexa CH2 group is called methylene. CH2 is methylene. How many times methylene? 6 times. Hexamethylene diamine is a common name. In case of IUPAC, 6 carbons are there. That's why hexane 1,6 diamine. 1,6 diamine. You understood this?
Yes, yes, sir.
Next, aromatic started. Benzene ring plus amine. We can say benzene plus amine, benzene amine. Or aniline. Aniline actually common name. Aniline is common name. In the organic compounds, maximum common names considered as IUPAC. Okay.
Yes, sir.
Next, this is actually toluene. Benzene plus methyl toluene. Here amine is there. Toluidine. Toluene plus amine, toluidine. The ortho indicating 1,2 position. Do you know that ortho para?
Yes,
Ortho meta para?
yes, sir.
This is the ortho position. This is also ortho position. This is the meta position. This is the meta position. Next, this is the para position. Ortho, ortho, meta, meta, and para. So here, with respect to of NH2, methyl is at ortho position. That's why orthotoluidine is a common name. What is the IUPAC name? It is actually toluene. So toluene. Then second position, amino. 2-amino toluene. 2-amino toluene. Or we can write benzene amine also we can write. 2-methyl benzene amine. Like that also we can write. You can see this one. Para-bromo aniline. Aniline means this much. Para position bromine. Para-bromo aniline. Otherwise, 4-bromo benzene amine. If you give the numbering from where you will give 1, then 2, then 3, then 4, then 5, then 6. Why we started from NH2? Because big functional group. Main functional group. So number 1 started here. 1, 2, 3, 4, 5, 6. Fourth position, bromo is there. Bromine. 4-bromo benzene amine. Otherwise, 4-bromo aniline. Okay. Suppose in this aniline, if nitrogen has any substitutions, then you can keep N, N dimethyl this much over. N, N dimethyl over. Then benzene amine. In the benzene amine, nitrogen, on nitrogen, 2 methyl groups are there. So first I am writing benzene amine. This is the substitutions. These are the substitutions. That's why N-cation dimethyl benzene amine. If you have any doubt in this, you can ask, then I will write in that page. These are the names, okay. 13.2. C4H11N. Write the structures of different isomeric amines corresponding to the molecular formula. C4H11. That means 1 carbon, 2 carbon, 3 carbons, 4 carbons. Then NH2. Once we can check it, here suppose 3 hydrogens are there. 2 hydrogens, 2 hydrogens, 2 hydrogens. 6 hydrogens plus 2, 8 hydrogens plus 3, 11 hydrogens. So 11 hydrogens, 4 carbons, nitrogen. This is one of the compound.
Yes, sir.
Next time we can write this CH2 group, we can write other side. This CH2 group, I can keep it on this nitrogen also.
Yes.
Then what will happen here? CH3, CH2, CH2 only 3. Then nitrogen, 1 hydrogen only. Remaining CH3 I am writing. The CH2 I am writing outside. So it was primary. Now it is secondary. Understood this?
Yes, sir.
Then one more, sorry, here CH2. Okay. Then one more CH2 you can substitute on this. Then N-cation dimethyl ethanamine. So primary, secondary, tertiary, you can write it. Okay, like this. Next, preparations. So we need NH2 group. So nitrogen related compounds we can take first. That is, I am taking nitro groups. See, benzene ring is there, benzene ring is there. From NO2 to NH2. What to do? Just reduction we need to do. Just reduction. Okay, for reduction, what are the reagents? So hydrogen, palladium. It is a good reagent for unsaturation. Hydrocarbons also. Even alkene and alkyne is converting into alkanes. What it is? Palladium and hydrogen. In the presence of palladium, hydrogen. Even nickel, platinum, palladium 3 are there for hydrogenation. But here, for nitro group, only palladium working. As well, tin HCl or Fe plus HCl, metal plus HCl. Okay, these are also acting as good reducing agents. The NO2 becoming NH2. Okay, 3 reagents we learned here. One is hydrogen, palladium, tin HCl, and iron HCl. From nitro compound we can prepare anilines. Is it clear?
Yes, sir.
Yeah, you need to remember these 3 reagents. Right.
Yes, sir.
Next, ammonolysis. Ammonolysis of alkyl halides. Ammonolysis. See, hydrolysis means what? Addition of water. Ammonolysis means NH3. Okay. So, ammonolysis of alkyl halides. Alkyl halides and react with ammonia. What will happen? Generally, substitution reaction type. So, one hydrogen leaving and one R group is substituting. You can see here. Initially, we can take NH3 plus RX is there. So RNH2 is forming. Then RNH2, again if RX is reacting, secondary is forming. If second is again react with RX, then forming tertiary. Again, if it is react with RX, then it is forming quaternary ammonium salts. Okay, this is the alkyl. What is this? Ammoanalysis. Ammoanalysis of alkyl halide. Why we are calling ammoanalysis? Because we are taking ammonia. In the ammonia, all hydrogen bonds are breaking. Here, first hydrogen bond breaking, R is substituted. Then second hydrogen bond breaking, then R substituted. Then third hydrogen also left. Then here it is forming salt. Understood?
Yes.
Next, here this point important. The order of reactivity of halides with amines is Ri is higher than Rbr than RCl. See, what is the question here? Which alkyl halide can form easily amines? Okay, in that case, what to do? We need to actually, if Ri is there,
It will break easily with iodine.
with iodine, because bond length is more. Length is more, easily break up. So easily breaking, the new compound is forming. So reactivity where it is more?
With iodine.
Yes. Reactivity, the one is higher than the two. Iodine is higher than the chlorine. Ri is higher than the RCl.
Yes, sir.
Okay. You can see Ri is more than Rbr than RCl. What was the reason? That bond strength only.
Yes, sir.
Okay. Ethyl chloride ammoanalysis NH3 I'm taking. Then one of this alkyl is substituting on hydrogen. Then second time substituting. Then third time substituting, like this form. Then benzyl chloride. Then reaction with NH3. Same. Okay. So we prepared from nitro group as well as from ammonia, from these two compounds. Now cyanides, from cyanides also we can prepare. Okay, what should do here? Just do the reduction again. The pi bonds are there, you make it reduction. So this reduction, this carbon also CH2, NH2, 2 times, hydrogen and hydrogen, hydrogen and hydrogen. So what are the reagents? H2 nickel. Actually nickel, platinum, palladium, all these three are good reducing agents. So here we are taking hydrogen nickel, then sodium amalgam, ethyl alcohol. Sodium amalgam and ethyl alcohol. So we need to little bit remember these things, cyanide to amine. Generally reducing agent, that much we can remember, but the next step, the clear nickel and hydrogen in the presence of sodium amalgam ethyl alcohol. Okay. So cyanide, from cyanide also we can prepare. Then reduction of amide. Reduction of amide. If you do the hydrolysis, partial hydrolysis, RC triple bond N. If you do partial hydrolysis, you will get amide. Yesterday we got it, this reagent LAH, lithium aluminum hydride. I told you that if yesterday we discussed carboxylic acid is becoming alcohol. So here also amide is undergoing reduction. Nitrogen containing groups reduce it to amine. Oxygen containing functional group into alcohols. Nitrogen containing functional groups reduce it to amines in the presence of lithium aluminum hydride. It is a strong reducing agent. Many times it will repeat.
Yes, sir.
Right. Then it is again named reaction. It is Gabriel phthalimide synthesis. So in the nomenclature, I told you this phthalimide again it will come. Phthalimide, now it came. Phthalic acid, COOH and COOH is a benzene. So this is called phthalic acid. THCALI. Phthalic acid. This phthalic acid, if it is react with NH3, okay, then what will happen? Simply remove the water molecule. OH and H water molecule. Here OH and H, remove it. Just what we did here, we are removing water molecules. So now we got it. Phthalic anhydride. Generally, if you heat it, phthalic anhydride is forming, but in the presence of ammonia, it is phthalimide, amide. Actually, amide functional group is C double bond O, NH2 is the amide. Okay, here C double bond O, C double bond O. NH2 type is there. Phthalimide, phthalic acid. The source is phthalic acid. So it is called phthalimide. Then what we are doing here, we are reacting with KOH. It is little acidic, it is basic. So the K plus and H plus will exchange, forming salt, coming salt formation type. One is positive charge and negative charge combined. Then when Rx is there, in the Rx, R plus X minus. So the R plus is joining with nitrogen. This X minus is joining with X. Okay, here byproduct is KX. Then we are doing hydrolysis in the presence of base. In the presence of base, we are doing hydrolysis. H2O. Okay, this bond will break up. Here HOH, HOH. Again, primary amine is forming. Once again, I will repeat. Gabriel phthalimide. It is to prepare primary amines. Primary amines. So we are taking the raw material phthalimide. In the phthalimide, amide is there. Here one hydrogen is there. This is more acidic hydrogen. Acidic means we have to treat with the base. It is forming a salt type. Why we need to form a salt? Because if you want to join, if you want to make it alkyl group on nitrogen, if you want to substitute alkyl group on nitrogen, we should make it like a salt type. We should make it a salt type. Then only the new bond formation takes place between nitrogen and alkyl group. So simply K and X, KX is forming byproduct. R is substituting on nitrogen. This 50% over. Then what we are doing, hydrolysis in the presence of base. So the bond will break up here. So the original compound again it is forming, instead of phthalimide, it is phthalic acid, phthalic acetate now. Not phthalic acetate. This is the phthalate, sodium phthalate, sodium phthalate. If you do the hydrolysis, phthalic acid. If you heat it, phthalic anhydride. If you reaction with ammonia, phthalimide. So this compound again we can reuse. This compound we can reuse. It will goes to here. Then slowly it will come. Again reuse. This is our main product. Gabriel phthalimide synthesis. You understood, or shall I explain in the another paper?
So can you like write and explain? It's a little confusing.
Okay. Phthalimide. The structure you had to know, the phthalic acid byproduct, phthalic acid derivative, that is phthalimide. This phthalimide you understood now?
Yes, sir.
Okay. So amide, so it is acidic hydrogen. Okay. See, what is our aim is what? RNH2 I want to prepare. Okay. I want to prepare. This is the purpose. What is the purpose or aim? I want to prepare amines. So here one nitrogen is there. I want to join one alkyl group here. Alkyl group. So whenever you want to join the alkyl group, you should take it in the form of ionic. In the form of ionic. Then only you can join the alkyl group easily. Okay, right. So what I'm doing now, I'm treating with the, it is so acidic nature. I'm treating with the base, that is KOH. Then what will happen? Acid react with base and forming salt. Double bond, and here K plus OH minus. So OH minus H2O, it is living as H2O. You understood this much?
Yes, sir.
So now we can join any alkyl groups with this nitrogen. So now I am taking RCl, any RCl. So here N minus is there. So this R group can join with this. So here actually R plus Cl minus. So this K and Cl is forming KCl. Then this phthalimide is nitrogen is there. Instead of K, now it is sitting R group. This much only. This step also clear?
Yes, sir.
Right. So almost our product is ready. RNH2. That means RNA already is there. Just you need to remove this area, unwanted area. So what I'm doing here, I'm doing hydrolysis. If I do the hydrolysis, I will get it. C double bond O, however it is there. In the hydrolysis, what's happening? Here hydrogen, here OH. Here hydrogen, here OH. Okay, OH plus or NH2. This is the final product.
Yes, sir.
In the textbook, what they did, instead of acidic hydrolysis, they did basic hydrolysis, NaOH. They took this NaOH. If you take NaOH, what will happen? Salt is forming. Instead of acid, salt is forming. Na plus, CO minus. CO minus, Na plus. If you take NaOH, this is the product. If you take H3O plus, phthalic acid is forming. Here the product, main product is same.
Yes, sir.
Okay. Sir, which should I take means both you can take anyone. If you take acidic medium, acid is forming. If you take basic medium, salt is forming.
Yes, sir.
Okay. This is the Gabriel phthalimide. Okay, last one reaction is there. Preparations, properties, tomorrow we can discuss. This is again named reaction. Hoffman, Homfort. In movies, they will say Homfort means they will make it disappear. Okay, Homfort, Gayab. Okay, so like that we need to remember Hoffman bromamide degradation reaction. So degradation means decreasing, nothing but degradation. Hoffman is a scientist name. Bromamide degradation reaction. So in the name only is there, bromine is there, and some decreasing word is there. Okay, this much information is here. What we are doing here, from amide to we are preparing amine. Amide to amine. What is the change here? Just we are removing this CO. What I explained there, Homfort, what Homfort? This CO is Homfort. Hoffman. The CO is eliminating. Or NH2. Bromamide degradation. What is the degradation? Carbon is decreasing. That is only degradation. Degradation means one carbon decreasing compared to the initial compound. Here, one carbon decreasing. Bromamide. Bromine we are using in the presence of NaOH. Final conclusion is what? Simply we are preparing amide to amine. Amide to amine. What is the reagent? Bromine in the presence of NaOH. Okay?
Yes, sir.
If you
Yes,
take
sir.
CH3, C double bond O, NH2, you will get CH3, NH2 only. Got it? This CO is removing.
Yes, sir.
Okay, this is the reaction, including balancing is important. 4 moles of NaOH is required. Bromine is there. So 2 bromines, 4 sodium means 2 moles of NaBr is forming. Then still 2 moles of Na is remain. That is Na2 and this carbon. Na2CO3 is forming. The byproduct is water. Or NH2, amide to amine. The byproducts are sodium carbonate, sodium bromide, and water.
Yes, sir.
Okay, so once again recapitulation. What we did initially, we took nitrites. The nitrites just directly reduced by palladium and hydrogen. Then we did from NH3 reaction with RX. Then what we did is cyanide. Already nitrogen is there, just reduction only. Then what we did this Gabriel phthalimide amides we took it. Then Gabriel phthalimide again. This is also phthalimide only. This is also amide only, but we are removing just CO and making direct into amines. Amide to amine. Okay, so almost nitrogen is there in that. Simple compounds we are taking and making into amines. Okay.
Yes, sir.
Okay, once you go through that, then physical properties and chemical properties tomorrow you can discuss. 7 page means okay, 2 to 3 classes
Yes, sir.
you can complete. It is a small big it will take less time.
Okay, sir.
Okay.
Thank you, sir.
Okay, thank you. Welcome.
Right.
Good night.
Good night, sir.